Welcome to the Explainer. Today, we're going to peel back the layers of our digital lives to find the one single concept that underpins literally everything you do with technology. So, let's just start with a quick question. I want you to think about the last photo you scrolled past on your phone, the song you streamed this morning, or even this presentation you're watching right now. What is the one fundamental thing they all share? Believe it or not, the answer is pretty simple. At their very core, they're all made of the exact same thing. A massive, and I mean massive, collection of tiny two-state decisions. An almost endless series of on or off, yes or no. And that simple little on-off switch, well, it has a name. Think of it as the fundamental particle of our digital universe. It's the atom of all information. So let's get to know the bit. You know, the name itself is a pretty neat clue. It's a portmanteau, which is just a fancy word for two words smashed together. In this case, binary digit. And that's exactly what it is. It's the absolute smallest piece of information a computer can possibly understand. And this is where the magic is. The beauty of the bit is just how simple it is. We can call it 1 and 0, on and off, true and false, yes and no. It really doesn't matter. They all mean the exact same thing, a choice between two distinct states. And this simple duality, it's the bedrock of all digital logic. Everything. So where did this word even come from? Well, the term bit officially entered the scene back in 1948, thanks to this groundbreaking paper by a guy named Claude Shannon. But, and I love this part, Shannon made sure to give credit where credit was due. It was actually his colleague at Bell Labs, John W. Tukey, who had casually coined the term a year earlier. Okay, so the idea of a 1 or a 0 is simple enough in theory, but how does it actually exist in the real world? How do you make a bit? Let's take a look at how this abstract idea takes on a physical form inside our gadgets. And wow, the way we've stored these bits has evolved like crazy over time. We started with purely mechanical things, like the old punched cards used in looms, where a hole meant on and no hole meant off. Super simple. From there, we moved to electrical relays, then to magnetic cores, and now we're down to these microscopic silicon transistors, where the presence or absence of a tiny little electric charge represents that exact same simple bit. Okay, but let's be real, a single yes or no isn't very useful by itself. You can't write an email or store a photo with just one bit. It's kind of like having only one letter of the alphabet. So the crucial next step is to group them together to create something more meaningful. Now, the most common grouping, the one you see everywhere, is a little team of 8 bits. This unit, first named by Werner Buchholz at IBM way back in 1956, is called a byte, and that's a term I'm sure you've heard before. So, why 8? What's so special about that number? Well, it was really just a practical decision. You see, with 8 bits, you get 256 possible combinations of ones and zeros. That was more than enough to represent all the letters, numbers, and symbols you'd need for text. It just worked. And from the byte, we just keep scaling up. We group thousands of them into kilobytes, millions into megabytes, and billions into gigabytes. These are the units we see every single day when we check our file sizes or see how much storage is left on our phones. So let's bring all of this together. How does this microscopic world of binary choices actually show up in the speeds and sizes we see and deal with every single day? Okay, here is something that trips up a lot of people, the difference between a lowercase b and a capital B. When your internet company talks about a 100 megabit plan, they're using that lowercase b for bits. But when you download a file, its size is measured in megabytes with a capital B. And since there are 8 bits in a byte, that 100 megabit per second connection can theoretically download about 12.5 megabytes of actual data per second. Big difference, right? This also explains another classic tech mystery. You go out and buy a 1 terabyte hard drive, you plug it in, and your computer says you only have about 931 gigabytes. So what happened? Did you get ripped off? Nope, they're just speaking 2 different mathematical languages. The hard drive maker sells you exactly 1 trillion bytes, that's a decimal system, but your computer operates in a binary system, where a kilobyte is 1,024 bytes, not a clean 1,000. When your computer does the math, that 1 trillion bytes ends up looking like 931 gigabytes. All your data's there, it's just a translation issue. For over 70 years, the bit has been the undisputed king of information. But technology, as you know, never stands still. We've seen where the bit came from and how it works. But what's the next step? What comes after the bit? Well, the heir to the throne is something called the qubit, short for quantum bit. It's the building block for a whole new kind of computing called quantum computing, and this is a genuine game changer. So here's where things get a little weird in a really cool way. A regular bit has to be either a 1 or a 0. Think of it like a light switch. It's either on or it's off. A qubit, though, thanks to a quantum trick called superposition, can be a 1, a 0, or both at the same time. It's more like a dimmer switch that can be at any position, and all of them simultaneously. And this ability means it can hold and process an absolutely massive amount of information, way more than a classical bit ever could. And that leaves us with a pretty fascinating question to think about. Our entire digital world is built on a foundation of simple binary choices, on or off, yes or no. So what happens when that foundation changes? What becomes possible when the fundamental unit of information is no longer forced to choose?